If you've got a 92 to 95 Toyota truck or 4Runner with a cluster like this that uses an electronic speedometer and it stopped working, I'm going to tell you the most likely cause of that and how to fix it. Start with the most likely cause. It's the capacitors. There are these little things, they're electrolytic capacitors, and over time they'll go bad and they'll ooze stuff to corrode the board. And the solution, there's two solutions. One is just to simply replace them, and removes just removing the solder off of them, taking them out and putting some new ones in there. And so I'm going to step through how to do that soldering if you've never done soldering. Another option, because the problem is that this when it comes out of the capacitor, the stuff that comes out of there, it's acidic and it dissolves away the board. And here's an example of it. Every board that I've seen for this speedometer cluster has looked like this, where it's black on the top and the bottom looks fine. And so it eats it away. This one I tried to fix because there was a bad connection, and then I found another bad connection, and it wasn't worth it. So if you got a bad board, or what is a better long-term solution, because even if you fix one like this, it might keep corroding. You want to clean that off of there with like rubbing alcohol, something to get the acid off there, because the stuff that came out, these ones are good, but the stuff that came out of there is still eating away at the board. So if you fix your board, clean the thing off both sides, and then replace the capacitors. If your speedometer is still working right now, replace the capacitors, because it's going to end up looking like this. So the option is, like, this board was bad, what do? I went to a salvage yard and I got another bad board. That's where this one came from, but I was able to use parts for it to get my other one going. So the board from a third gen 4Runner from 96 to 97 is compatible with this. The odometer piece is not, and you got to swap that out. So I'm going to step through how to swap that out, and step by step. So I did that on mine. It's got a newer board on it that looks really beautiful, and I moved the needle over. And so what ended up being is that on the speedometer here, the shaft on the 96 to 97 is a little smaller. And I planned on moving over the needle because it's nice and bright and looks beautiful. But the tachometer one wouldn't go on there because the shaft is smaller on this one than the 96 to 97. So on the video I will step through how to disassemble the board and then put it back together, and then I'll show you how to test it using a pulse width modulator signal generator. And you can get these for about 10 bucks on eBay, and it does a square wave because that's what's coming from the speed sensor, and so then you can set it to any speed and test it. This is how to use the circuit board from a third gen 4Runner or a fourth gen Tacoma, which is kind of less unlikely, in a third gen truck from 92 to 95. So this dash instrument cluster is from either a 96 or a 97 4Runner. And what I did was I went on eBay and just searched for the year to see what was available on pictures. What you're looking for is the electronic speedometer with this pattern. The sensor button is just off to the side. All the Tacomas that I looked at didn't have the cluster with the odometer reset on it. They had a less sophisticated cluster, whereas all the 4Runners from 96 to 97, it was like a certainty they all had this pattern. So on the back here, there are, of the speedometer, the screws that hold it in, kind of like these, the screws that hold it in are the electrical connections. So I used this pulse width modulator before I started to test this unit. And what you do is the 4P is the pulse that goes out to the ECU. It's basically a repeat of the sensor coming in from the speed sensor. Ignition is positive and G is negative. The labels on the 3rd gen trucks are slightly different. The pattern is exactly the same. So you can put the pulse width modulator on there, signal generator on there, and then test it. Right now it's set to 33, which is about 30 miles per hour. It's 1.1 for every mile per hour. And then it will go up. It's pretty cool. So what I did is I removed these screws. This thing, you just got to get the plastic part. That's really easy. Get that out of the way. Unscrew the speedometer. Pull that unit out. Then this is out of the way. What I've already done is two things. Is pulled the needle off of there. So one of them I did was really easy, and the other one was really hard. One thing that you want to make sure of, this is my donor one, so I really don't care what it looks like, because I got to just get rid of it with this thing over here. But when you're working on it, this little needle right here is fragile. So you want to make sure that you don't break that on your vehicle that you need it for. So you take this needle off of there, use a screwdriver, get these two screws out of there, then you got the faceplate off. You're down to this, actually this plastic comes off too. And then, so this is the beautiful part. This board, it looks like brand new. This is what all the boards that look like that I've seen on the internet and everything that everybody had out of the 3rd gen trucks. It's all black on top from it dissolving, and the bottom looks fine. Whereas this thing, the whole thing looks fine. So what the deal is these two capacitors go out and then they ooze like something acidic all over there. And so this board had a bad connection. It's like between here and here, there was nothing. So I ended up soldering a jumper wire over, and then I found another bad connection. These are surface mount components, and see how there's like solder on there. The one that was up here didn't even have any metal left on the edge. So there was nothing that I could do. There was no connection left. So that's why this is a toasted board. This is the part that is the speedometer part of it. And this runs the odometer. When you pull this off, so what the objective is, this is the odometer from the 3rd gen truck, and this is the odometer from the 3rd gen 4Runner 96, 97. And you can see that the reset button for the odometer is up over a little bit, and that's why you need to swap the plastic out and then just use their board. So this is the one off of my truck, and what you do is take off all the screws on here except for these two. That's really important. You want to leave those two on there. There's going to be screws that hold the odometer motor, or the trip motor to the actually it does it all, the odometer and the trip. So you need to remove those screws. This one's kind of in there at an angle, and you want to remove the other screws. You want to leave these two screws on here because that's holding this motor onto there. And if you undo those screws, you risk the chance of breaking the wires, just like these are broken on here. Learn from my mistake. So yeah, leave those two on there. So right now I've done it, and then it's all kind of loose like this. And then the other trick is down in here, around on here. Notice they're broken, which it doesn't really matter because the screws are going to hold this thing on there tight. So when I pulled this one off, learning, I broke two little plastic tabs and made a little accidental discovery after completing the whole video. So this piece, when I was trying to disconnect the odometer from there by using the pick down in there, this piece of metal rotates. See, it's got two flat edges right there, and it's normally sitting in that position. So if you take something like a snap ring plier you can twist it so that those flat spots line up with this corners, because that's where that thing's there and that thing's there. So this was on here, and you want to twist it counterclockwise from the back side, counterclockwise 45 degrees, and then that will line up, and those tabs won't catch anymore. You might still need to get something because there's a little bit of lip on here, but that's why this thing turns. But you want to use something to twist it 45 degrees counterclockwise like that, and that's how this will release. Okay, so how to replace the capacitors. You want a solder sucker, spring loaded, and then you push the button, the plunger opens up, and it sucks the solder away. Sometimes if you're cheap, you can heat it up and tap the thing off of there. Much better off with the solder sucker. So get the old ones off and then put the new ones on. They're polarized. They're electrolytic capacitors are polarized, so they'll have a negative side. That's the stripe there and there going on that side. So there's my replacements. And okay, so the objective is to be fast. These capacitors are not very heat sensitive. There are other things that are heat sensitive, and the longer that you have it on there, the faster the heat dissipates into the board. You want a soldering iron with a nice point on it so you can put the heat where you want it. And then you also need, like I've got it at 480 degrees Celsius. So you need something that, a soldering iron that when you put it on there, the heat's going to go away, and so that it can power the tip up and keep that heat constant. I've got other soldering irons that just couldn't keep up. This one was relatively inexpensive, but you want to be fast, and you need some heat to do that so it doesn't go everywhere. So cock that baby again. Just looking at where the one is the resistor. Okay, so just one pass at it does a pretty good job of getting most of it off of there. You can see the thing wiggles. That one comes out. It's like pulling a tooth. And then that one comes out. Out with the old, in with the new. So then here's the new one. So we go here. If you've never soldered before, the objective with this is you want to like put the soldering iron on one side, heat the thing up, and apply the solder from the other side. The solder goes to the heat. You don't really want to be putting the object you're soldering has to be hot. So you don't want to melt the solder by using the tip. You want to use it by melting the surface that you're trying to adhere to. Yeah, that'll work. I really need reading glasses. I'm getting old. And I'm getting carried away. All right. All right. So that needs more. More solder to a certain degree is good. You don't want to heat a blob on there. But one of the things that can happen, these aren't really going to heat up too much, but heat can actually, in stereo amplifiers and stuff like that, you can, the solder can melt under the heat of the thing because it's not well ventilated. So look at this, inspect my work. So it all looks pretty good. And that's how quick it is. That's ready to just put back together new. When you buy capacitors, get ones that are rated for a high temperature because it's in the dash. And so like 105 Celsius is the highest that I've seen. I've seen other ones rated at 80, but it's just, you're going to be better off a higher temperature one. Okay, so here is the odometer, and that thing's all soldered together with the new capacitors. That goes in like so. Oh, that new capacitor was hit it. So these screws, there's going to be 2 screws that go into that motor, and that will immediately hold the thing together, whereas those tabs before did something. It's probably what in production the reason they wanted those tabs on there, because once you screw this together, these tabs that broke, it's fine. It's not going to go when you get those two in. So now that's solid. It's not going to go anywhere. Okay, so now this is the faceplate from my 93. Something backwards here. It was there. Okay, so the way that I'm going to end up calibrating this thing, so you got the needle there, always be careful of that, is to set this to a specific speed that I know where it should be on here, and then push the thing down. The needle rests on there with some tension on the spring. When I did the other one before this, I kind of guessed at it because it's really down there, and I lift it up over and put it like this. Remember, this is fragile. That's more fragile than this thing is. So what I'm going to do is set this to a certain speed, and like 30 or 50 or something like that, or probably somewhere in the middle of the range, and then I'll push it down and verify that the speed that I'm expecting is what's on here. So I've installed the speedometer back into my existing cluster, and I put the needle on. The battery died in the middle of the last video, so I'm starting over. So what I did to put the needle, so on the back of here, there's 4P, which is 4 pulses going out to the ECU that uses the speed in its calculation for fuel and timing advance and that sort of thing. So on the back of here, I connected negative to where it says ground and positive to where it's got positive. I've got a power supply. This one's really big. I started out with like a 1/2 amp, and it wasn't enough, so I just grabbed the big one. So it won't run a real small one. I don't know what the amperage requirements are though. So that's 12 volts out. This is a pulsed width modulator signal generator, and so what the deal is that the speed sensor itself turns 1,000 times per mile, and it pulses 4 times for every time that it turns. So you have 4,000 pulses per mile. What it pulses is really interesting. So I bought an oscilloscope. It pulses between positive and negative, going back and forth on the sensor wire coming from the speed sensor. This unit pulses the negative lead. On the back of here, you've got voltage in and voltage out, positive, but for this one, the positive out is basically the same as the positive in, so it's not pulsing that one, it's pulsing the negative. So whatever pulse generator that you get, you need to connect to the signal here. The speedometer cluster will work with a negative pulse or a positive pulse, which is really interesting. I set this up at 50% duty, which is half the time on, half the time off. The duty cycle doesn't matter if it's, I just put it at 50%. So this thing is pulsing the negative, so I hooked the negative up to here. I had a different one that pulsed positive, and it'll work on both ones. So this 4P that's going out to the ECU does the same thing. It repeats exactly what goes in. So it goes between positive and negative, and then the ECU uses that in its fuel and timing calculations. So we'll plug this in. So I got this set to 11 hertz, which is roughly equivalent to 10 miles per hour. So there are 3,600 seconds per hour. So if you divide 4,000 miles by 3,600, you come out with 1.1 hertz per mile per hour. This thing has a decimal point because it's reading in kilohertz. So when you adjust this, so right now it's pulsing and it's doing a square wave on and off. When you change the frequency on this, you don't want to hold the button down, because it will just zing and go really fast and give it a really high rate. So I just click a whole bunch. You can go down really fast, just not up. All right, so if I go up to, like, say 66, actually let's go 67 because we're going to round up. That should be about 60 miles an hour. The same observation on this as with the other cluster is that it's not accurate through the entire range. So to a certain degree, the way I put the needle on there is I pick a speed, I did it at 30 miles an hour, so it's accurate at 30 miles an hour. So right now, if I wanted this to be more accurate at 60 miles an hour or 65, that's where I put it on, because it's not perfectly accurate going through the whole thing. The other unit was the same exact way. Interestingly enough, my tachometer, I've always adjusted my idle higher than the spec based on this tachometer. And then I hooked an oscilloscope up to this. I used this wire to observe what's going on here, and then the oscilloscope can lock into the frequency and tell you, like, how many RPMs it's doing. So on that, so this is RPM, and it's pulsing twice per revolution, because it takes 2 revolutions for all 4 cylinders to go. And if you look at this faceplate, it's got a 4 on here. A 6-cylinder will have a 6. There is a potentiometer on there to adjust it, which I'm going to do before I reinstall this. Or actually, I'm going to have to install it to adjust it. I haven't figured out how to simulate the tachometer signal. This didn't do the trick. It's expecting more of a spike, I suppose. So I've always set my idle higher than the spec based on this, and then when I use the oscilloscope and to read what it was doing, this was reading higher than the actual speed of the motor. And so that's probably why I've always set the idle higher than the spec, because I was going off of sound and behavior. So before I seal my dash back up, I'm going to calibrate this, and the only way I figured out how to do that was a potentiometer, but you can't get at it while it's installed, and I don't know how to simulate this signal. So I'm just going to turn it down a little bit and then test it relative to the what the oscilloscope says. Yes, that's this pulse width modulator does. It's great for testing this. Like I said, you only want to put it up like one at a time. If you hold that button down, it's going to just go zing fast, and then the needle will fly. So like I can put it down and it'll go real fast. So this is the needle from the new unit, newer unit. It's nice and bright. That's why I stuck it on there. The design is slightly different, a little bit bigger, and doesn't have that bevel on it. I'm going to take, so this is the older one there. And it used to be bright. You can look down in there and see a little bit of the orange. So I'm going to take the needle off of that other one and place it on this tachometer. So in this thing, if you lift it over the needle, that keeps it from moving, that's like its resting position. So what I'm going to do is take this needle off there, because the spring is on there, and then put it back on, so it's at the right spot, and then go to here and lift it up over. This little pin right here is fragile. Don't want to break that. So yeah, I'm going to replace that, make it look a little better. And I believe that's it. Now let's turn this off. So just to give you a good look, it's kind of upside down. So yeah, the screws that are holding on, and that's just how you can do it. Anybody selling one of these used units anywhere, they're selling for like $150 and they're not testing them. If you're selling a unit for $150, you should invest $10 in this, so at least they know that they're getting the right one, or getting a working unit when they're getting it. And any old unit, I'd really recommend just if yours is working right now, I would replace the capacitors before this happens to it, because it's going to happen. It's just a matter of time. It was a 10 microfarad and a 100. The one I took out of the 4Runner from the 96, 97 was 2 100 microfarad. I used my meter to test the capacitors that I took out of the 4Runner, and they were at like 108, which is within specification. The capacitors that I took off of this board and off of the other board, well, the legs were getting dissolved and eating away. So two of them were actually the one on this board. This came from a salvage yard. Both of the capacitors were standing on one leg. The other leg was just dissolved and gone. I tested those because there was still a place to stick it in there, and they were way out of calibration and like 100% or 200% off. My board, the original one that came out of this unit, it had one capacitor was still good and the one capacitor was bad. And as far as the leg, because it was also just standing on one leg, the other one was gone. And when mine went out, it made a noise, and I think it was just shortened across that leg that until it was eating it out. And so what ended up happening is that was on the Speedo. So these two capacitors, one side of this board drives the speedometer and one side does the odometer. This is the speedometer up here, and this is the odometer, roughly the odometer down here. But the capacitor comes down. So you can have it fail just the speedometer, because it's the capacitor, probably I think it's on this side here, is the one. So, and that's what would happen with mine. So that means this one's dying and that one's going to die, but you should replace them both. If this unit is not working, those capacitors are gone, there's a part down here that relies on them to create that 4P out to your ECU on your computer, on the EFI. So if your Speedo goes out, excuse me, it's gonna alter something in the EFI, but I don't know what. It's part of, I just imagine there's this big weighted variable equation, and that's one piece in there, because the ECU looks at everything, including your brake light. So if the speedometer is not working, the computer's just going to think you're not moving the whole time. And I don't know how that's going to alter its equation, but you definitely want to fix that. So, okay, so this is my instrument cluster, completely assembled with the newer circuit board from the 96, 97 4Runner. My plan to use the needle from it on my tachometer didn't work, because the hole on this one is larger than the shaft on the older model, so it doesn't stick. If you wanted to use your existing needle, to on the gauge. You could just drill it out to be a little bit bigger to fit on top of the 96, 97 4Runner shaft. The tachometer board from the newer one is in no way compatible. It's not even close. If you have one of these and the speedometer hasn't failed yet, it is most likely gonna fail, and it could take the circuit board out with it. So it would be good preventative maintenance to replace those capacitors now. Hope you appreciate this video. This took me a while to figure everything out. If you could subscribe to the channel, give me some likes. There's some other videos that I'd like to create. I've been exploring through reading the manual, and have a good day. This video is sponsored by California Trail Map, the most accurate trail map available for California and Nevada. The color of the trails indicate how they can be used. Street legal motor vehicles, off-highway vehicles, biking, horseback, hiking. There are 3 background options to choose from. The land boundary background indicates the type of public land. There's a topo gradient background. Then there's a transparent background that allows you to display the trail map on top of another map or satellite imagery. There are 7 zoom levels that progressively add details as you zoom in. This makes the map a lot more usable on small screens. There are icons for all the points of interest, with the more interesting points being displayed at a higher zoom level to make them easier for you to discover. The map loads into Android and iPhone apps, Garmin GPS receivers, TrailTech Voyager Pro GPS receivers, and can be viewed on a Mac or Windows computer. It's a one-time purchase for the downloadable file formats, and there's also a tile service that can be purchased with a yearly subscription fee.